Hello. Hey everybody. Oh my gosh. How's it going, Danny? I have to download this textbook real quick because I don't think I have it. This class is making me very depressed. So we had to print out for my fluids class. We have this thing called a supplemental handout, which basically just had a bunch of different values, tables, stuff for pipe flow, different densities, different, I don't know, pretty much anything you could think of, viscosities, all that kind of stuff, different pressures for like water at different levels, all that kind of stuff. And my professor was like, oh yeah, you know, this is like a department standard thing, so you can use it for thermo, you can use it for fluids, you can use it for thermo fluids too, like all that stuff. And I pull up, this guy's a new professor. Wait, let me switch to the couch. Oh my gosh, did somebody say thermodynamics? Wait, why am I evil? Well, actually I am evil. This guy's making me evil. I'm doing thermodynamics. This is the worst professor I've ever had in my life. Hi, bye, Rev. I have exam 1 on Thursday. I'm so fucked. I have my first. He doesn't have any midterms. He has 4 quizzes, and apparently the first quiz is next Friday. He's taught us the definition of what a unit is. Oh my, I'm gonna start doing Hamlet monologues in his class, I swear to God. He's not good. He started mansplaining the word optimization. Well, that's the first time I saw another camera angle on stream. Oh. Yeah, I do have this one. I don't use it as much because normally I'm yapping. I need to download this textbook real quick. But yeah, I have a supplemental handout that's filled with values. It's already printed out. It's like 30 pages. It's not small. It's pretty large. And he's like, no. You need to buy a physical copy of the textbook, which none of us, he asked like, hey, do you guys have the textbook? And we were like, yeah, we have the textbook because we have the PDF of the textbook because no one in their right mind buys a textbook for engineering class ever. Because no one ever needs it. And he's like, yeah, you guys have it, right? And he's like, oh, bring your textbook to the quizzes. And we were like, what? And he's like, I'm not gonna give you the tables, just bring your textbook to the, like, dude, just give us the tables, At this point I completely ignored she does in class and then teach myself everything from the textbook. She wants us to have it IRL. For steam tables and entropy graph. I literally have those in my other thing. And he's like, no. We're not teaching you how to use those tables. We're teaching you how to use this textbook's tables. I'm like, bro, this is a department PDF. Everybody uses this except for you, because you're new. He's like a retired guy. Like, I hate it when I get a professor and it's like, oh, I've worked at Raytheon for 17 years, I've worked at Lockheed for 20 years, I've worked at Draper for 30 years, and I'm retired and I'm gonna teach now because apparently that makes me qualified to be a teacher. Bro. Sorry. You can tell I'm pissed. Realizing I have to fight the Thor Marvel holding Bog Junkus. I love Marvel. Oh my god, I was so mad after. I try to be very polite about my reactions in class because I tend to be pretty. Yeah, I'm a very reactive guy. If I don't like somebody, like, I wanna, it's hard for me to not show that. But this guy, I was sitting in like the front row face palming because this guy was so bad. I was like, I can't not. Okay, I have to actually find this. Wait, I think it's on, one sec. He literally said we could use a PDF, and then he said, oh, just print out all of the tables. Oh my god. He's gonna make us use like 2 tables. I'm calling it. Sorry. It doesn't matter at all, you guys. No. Oh, there we go. What is this? ME, I don't know the number of this class. 302, I think? I gotta scroll down a little bit. Sorry, this is so awesome to watch. Fundamentals of Engineering Thermodynamics, 8th edition, I think he wants us to have the 9th. He's not getting the 9th. Tell me how they're using DUDT in thermodynamics when it only cares about the states. Is there a DT? Oh, that's so interesting. So that's like a fluids thing. Because, you know, you might have an internal energy change, right, over time, but it kind of just depends on what your system is or how you're defining it. You know? Literally playing Geometry Dash while I'm in this stream. I've heard that in the thermo, you basically just do everything steady state. But in fluids, you don't do that. So I don't know. Because when we do Navier-Stokes, or when we do, well, geez, Navier-Stokes, when we do Reynolds transport, we do, in fluids, we have to assume that it's steady state. Let's see, Moro should be, okay. That's the right one. Please work, please work. No, I don't want to request a PDF, ew. Google Drive, please. There we go. There we go. Let's go. Wow, this is a very engineering textbook. Here, you guys can experience this with me. Where's this? Game capture, hello? I don't know if this is gonna capture. Yeah, here it is. I don't know where we're going. We're going to chapter 1, I think. Somewhere. Oh, people jump scare. Oh, I can't skip. Ugh. That's chapter 3. Evaluating properties? Evaluating properties? Oh my god, I'm gonna lose my mind. There's apparently 3 lectures on control volume analysis. We did control volume analysis for like 2 weeks in fluids. I'm gonna lose my shit. Alright. What? Using the internet? Oh my god. Guys, how cooked am I? How cooked am I right now? Fuck, okay. No, not the unit questions. I'm gonna cry. Please don't make me. Please. Okay. I'm being so dramatic, but also it's like... Alright. The Phoenix, with a mass of 350 kilograms, was a spacecraft used for exploration of Mars. Determine the weight in newtons on the surface of Mars where the acceleration of gravity is. I'm gonna cry. Can you multiply 2 numbers together? You're a third-year engineer. Multiply 2 numbers together. Do you know what a unit is? Do you know what a dimension is? Fuck you, dance monkey. This is my insanity era. Guys, this is my insanity era. He's also making us write our givens. If I have to write any more givens, I'm gonna start blowing them up. I don't know if it's true, but I heard that Mechie Thermo is easier. It probably is. It probably is. I don't know why. Dude, everything Mechie is easier. Mechies get like... Well, also, this is like... I don't know, this is the easiest... shit. Well, this is not really fair to say. This is like... This is week 1. I don't know why every single textbook does this, but they do this. Can you multiply numbers together? See, at least my fluids one, we had to do this with fluids-related things, not just like weight. I feel like I'm a baby. Let me... Ours didn't? Oh, stop! This is how they torture me in hell, by just doing unit conversion problems. You ever heard of a pound mass? You don't know what a pound mass is? Oh, king. Get ready. Pound mass, slug. We don't actually really use slugs, we tend to use pound mass. It's just dumb. It is dumb. Welcome to the English system of units. I don't like it, nobody likes it, but we all use it. What the fuck is a gallon per feet? I hate that shit. I also have to do it. God, doing fluids I think is particularly dumb because anything with fluids or power transfer, horsepower. Why does a horsepower exist? What's a pound mass? Oh, a pound mass is the English equivalent of a kilogram, essentially. So kilogram is a measure of mass. It's like how much matter something has. And then in the English system, we have two different units actually for it. There's one called a slug, and there's one called a pound mass. And these are both derived from different things, but they're two units. They don't equal the same thing, but they're both ways of expressing. This one is a little bit easier to express because it tends to equal 1 pound force, but it kind of depends on gravity because the conversion it does not matter. It does not matter. I saw him using specific gravity in class, and my ass who took this measurements and analysis class was like, did you know that specific gravity is actually less good to use in most cases because the elevation of the Earth is different at different points? If you don't know the exact elevation above sea level, you shouldn't be using that much specificity in your gravity answer because... Thank you for head pads. Oh, I hate that I'm becoming that guy, but I'm also that guy. Like, if you're gonna make me take a class, and you're gonna make me remember that 32.174 is how many slugs in whatever, and you're gonna make me remember that 9.81 is the most specific gravity you're allowed to use, then... Thanks, Amazon Prime. Oh, nice. So, thank you for this. I really wanted to do a donathon because I'm I was $10 away from my first ever Twitch payout, but now I'm like $5 away, and I just think it'd be really fun to do a donathon for only like $5. Alright, atomic and molecular weights of some common substances are listed in Appendix Table A1. I'm gonna pull out my thing. If the table is in here, I'm gonna shit my pants. Using data from the appropriate table, determine the mass in kg. Okay, I'm on page 48. Where do I get to the tables? I don't want to have to spend like $20 printing this. Ugh. Minecraft hurt noise. Well, let me look up in my printed version first. Not of this, okay, so we're looking for the mass in kg of 20 kmol of air? Bro, that's... Oh my god, they're not gonna be the same. There's no way this is the same. What air? The density of air changes based on the temperature. I'm so normal. Oh, here we go. Molar mass kg per kmol I'm getting 28.79. That's what my handout says. I'm so mad at this guy. You know, it's kind of funny because I really disliked one of my professors. I thought was one of the worst professors I ever had. He is still one of the worst professors I've ever had. He just kind of stopped teaching the class at some point, and he didn't teach us what a phaser was. And I was like, yeah, this guy really sucks. I really don't like going to his class. The lectures are not good. This guy, my professors this year are crushing all of the previous professors I thought were bad. I cannot believe anyone has made me say, man, I wish I could take my EE professor again. It's crazy to me. The Stockholm Syndrome. Okay, so air is... We want the mass in kilograms. Okay, so molar mass kg per mole. So air is 28.97 kg per kmol. This is Han. Oh, well, I won't say Han, let's say fluids. But yeah, some of these things depend on the temperature and the... Normal. Okay, carbon. Is it in here? No. It might be in a different table. If I can get H2O. Probably, maybe. Different table. Okay. Not doing too well, but I think I can get CO2. CO2's in here. Yeah, CO2 is 44.01 kg per kmol. And let's see if I can find water. So, oh, I guess because it's maybe... Those are gases. But carbon? Carbon? Like, straight up carbon is not a fluid. Well, I mean, I guess it could be a fluid. Properties of water. Look at how the density of water changes. But I guess that's not the density. They want the camel. Let's see. It might be in here somewhere. I'm looking for things that I have not looked up before. They don't really ask us for camel and fluids. Or mass per... What is camel? Kilomole? I guess. Let's see. It doesn't look like they're giving it to me, which is a little sad, but then again, who asks for carbon in a thermo class? Come on, man. Properties of engineering materials, maybe it's in here? No, carbon is not just you don't just use carbon. Pipe flow. Very nice. Nominal diameter, that's pipe flow, dimensional analysis, and we've gone past all the tables. Wait, no. Properties of common liquids and solids, this is some stuff. Carbon, I have the water content of apples. Aha, I found it, carbon. 12 point, wait, why did I not just know that off the top of my head? That's actually kind of embarrassing. 12.011. That one is on the, ooh. That's kg per kilomole, yeah. That's on the periodic table. Ooh. And then water, H2O. Is not on here because, of course it's not on here. Today's your birthday? Oh my gosh, thank you so much for the sub! Happy birthday! I hope you're having a really good birthday. Sorry we're fighting the Lich King on your birthday. I can't find why. Can I just get the... I know what it is. It's... I could just find what hydrogen H2 and then add O. Fine, I'll look it up in their table. Oh my god, oh my god. Oh, Jesus Christ. Oh my god. Guys, I might have to buy this textbook. Set it on fire in the middle of class. A1 and A1E. Why is there an A1E? Okay, we're gonna go on an adventure together. Look at all this information that I don't need to know. What? Look at this! This is crazy! Why would you have all this in here? Oh, A1. I missed it. H2O. 18.01. Let's see if it's the same. Carbon. Mine is a little more accurate. Air. 28.97. 20.97. Okay, so it is the same. And then we'll just do book. I'm gonna say yes, yes, yes. Wait, CO2. 44.01. Yeah, 44.01. I mean, I don't know how you would get it wrong in a table like this. It's just rounding error, possibly. H2O is 18.01. O2, sorry, O2 kg. Cool. So those are all good. Engineering lettering. I say fluids handout. It wasn't really a handout, it's just a supplemental, whatever. Now the mass of 20 kmol. So let's do a... I guess, how would I write this? 20 kmol air equals... it's gonna be the right thing. I'm just multiplying numbers by 20. I'm like an old angry grandpa. I don't want to multiply my numbers out. Just give me the problems to do. Alright. I typed in the wrong. Fuck. 20 kmol CO2. 880.2. I'm actually surprised that the density, the molar mass of water isn't in here. Maybe it's so common that they're like, why would you need that? There's some hexane and stuff in here. Like toluene's in here, benzene's in here, light diesel gas. These are all things that, you know, what more do you need than that stuff, truly? Let's see if I can find the other ones in here before I flounce around. I think he only asked for us to turn in these 2 problems. I don't really know. He said turn in like 8 and 9, and I don't. But the assignment said there were like 20 problems we had to do, so I'm not really sure who to trust, but I'm gonna do these 2 right now. Alright. Oh, you can't see what I'm writing. Fuck. You've just been looking at this table the whole time. I'm so sorry. That must have been even more boring than... Jeez, it's already boring enough. Right, we'll quickly do a cursory look for these ones. H2, N2, NH3. Let's see, H2. The H2 is in here. N2. C3H8 is in here. The N's are not, but they might be somewhere else. Let's see. And then I might just do dynamics because low-key, this is kind of a waste of my time. If it's just going to be multiplying 2 numbers together, I don't want to subject you guys to that. I mean, the whole class is not multiplying 2 numbers together, but right now... Wait, what is viscosities? Oh, viscosities. Ah, the air one is good. Alright, N... Okay, N2 is in here. And... What is it? I want NH3? Oh, NH3. So all of them are in here. Look at that. Look at that, chat. Look at that. All of them are in the fluids handout, so that's awesome. Sorry, I'm just imagining if we had like, if we all pooled our money together to rent a physical copy of this textbook, because I'm sure it's prohibitively expensive even just to rent it. And we pooled our money together to rent it, and then we just passed it around. You get to copy down the values. Everybody, don't use it until the very end where you copy down all the values and you pass it around, you copy down all the values. I would do that. I would go halvesies on... Work smarter, not harder. Okay, let's see. So the homework 2... Oh, okay, he splits it up like hella. Why does he split it up that much? What? What? Wait, I'm confused. He has us doing homework 1, which is just 8 and 9, which was that. Oh, homework 2. Okay, homework 2 is due Wednesday. All right, that's fine. I'm okay with that. That's kind of funny. Oh, I have to do the syllabus quiz. I also have to switch that. Nah, it's fine. Okay, dynamics time. Well, that was all the work that I had to do. I mean, I guess I can... Let's see what the other ones are, at least. So 21, 26, 31. Oh god, I have to go back to page 48. I already forgot. 21. Oh, okay. That one's a little less bad. he's one of those, like, don't put multiple problems on the same page type guys. But he's gonna have to deal with it for right now. I can move them to different pages if I need to. 21, 26. Wait, but I could be doing this on my Tuesday stream. Uh-oh. Yeah, I'm probably gonna not do these. I just want to take a look at them though, because I think they're probably pretty easy. And then 31? Yeah. Oh, interesting. Interesting. Oh, that's not that hard. Okay. Some of these, I guess I'm gonna have to, like, go through maybe one lecture review. How's Moving Castle OSD? Yes. There's this one Ghibli Jazz playlist that I always put on when I am doing work that's annoying. And that's this one. Let me... Let's see. 8, 9, and then this is like 21, 26, 30. Okay. 2-pound sample of an unknown liquid occupies a volume... Oh, that's actually kind of annoying. I don't know if they're using pounds for pounds force or pounds mass. I want to say it's going to be pounds mass because in density that should be mass per volume. So we're going to say that a pound is a pound mass. The specific volume in feet cubed per pound. I actually don't know if we use specific volume. Maybe I did use specific volume. Let's see. We certainly didn't use it a lot. Wait, specific volume... I know specific gravity is like rho g. Specific volume... is... maybe not something we had to do. Yeah, specific gravity is a little gamma. Might be a more thermo thing. I'll have to look up the definition of that. Then as shown in this, it's initially containing with the onset of heating, gas pressure increases. At what pressure does a piston start rising? That's just a dynamics, I guess a statics problem, really. Yeah, wait. Does it give a weight of the piston? I should probably... Oh, it does. yeah, it does. Yeah, that's literally just a statics problem, so we're chilling there. And then... this one is just... yeah, that one's pretty easy too. Okay, we'll do those on Tuesday. I would like to... oh, wait! Well, first off, I got this right. This is... I asked her about it, and this is right. It was not right on the thing, but that was right, actually. This one... no, this one... okay, we did a problem in class where we were doing... what was it? It was a slider. This. And it was given like, we were given a speed this way and like a speed this way that it was turning. And we just used polar coordinates instead of using, because it's not really relative motion. And I was thinking maybe this one, because I remember we were getting this one goofed up. I was thinking maybe that might have been our issue, but I don't think that's our issue. I think the issue is something else. So now we gotta just like math it out, boys. Let's see. So VB is known. VB is given. We know that it's down this hill, which means that it's gonna be down and to the left. And that would be cosine of 30 and sine of 30. I feel like that's pretty good. Fine stuff. Okay. VB with respect to A. I could write this a little bit better, I'm not gonna lie. I should probably... yeah, let's write this a little better. So VB is what we're trying to find. Well, not really, but we are. Is VA plus VB with respect to A. This is 0, so VB equals that. Why did I do this first? Well, oh, actually, I know I did that first. Because I wanted to find the omega, and so generally how I tend to solve these problems is I will start with the equation that defines the variable we're trying to find. So if I'm trying to find omega, I want to define omega, basically. But in this case, because, I mean, we can kind of do it this way, it doesn't really matter. I'm going to do this instead. We're going to start with this. And then instead of doing this, I'm going to say that VB equals this. It's just a little bit shorter way of saying that. This is also the first problem, so writing this out like this... I gotta leave this room, I'm gonna be back in 15, 20 seconds. Oh, no worries. Have fun with whatever you're doing, or good luck with whatever you're doing. Sorry, my knuckles. I don't really need to define this here either. I can just plug it in. We know what it is, it's just a vector. If she gets on my case for that, that's fine. Okay, so let's check our cross product here. This I also don't, no, okay, I normally would just skip to this down here. I'm not gonna lie. But it's, again, it's first problem, so we'll do this. So R, B with respect to A, so we're going this way. Maybe I have the direction flipped. So it's supposed to go down. Ah, I have the direction flipped. Wait, no, B with respect to A is supposed to go this way. What am I talking about? What am I talking about? I'm literally debating myself right now. Okay, so it's negative cosine 20 times 0.15. Okay, we got that. And then sine 20. Yeah. Okay, that's right. I don't know what I was doing. I don't know what I was doing there. I'm gonna rewrite the cross product because I don't trust myself. JK, 0, 0, WBA. Maybe I flipped a cross product thing? Sine 20, 0. Because I know the thing is just, the issue is that we have 2 of these. I'm gonna get rid of all this. Why? Good question, me. Put that there. Okay. Now if we do this, here and here. I feel like I gotta stop doing that, but visually it makes me happy. I'll try to remember to erase it before I start writing anything else. So we've got positive, negative. So negative WBA. Omega BA. Times... No, because it's negative omega BA times both of them. So I don't know why... You can't not have that. Maybe I try it on different cross... Maybe I try a different row on the cross product. Let's try that. Let's do... I mean, I could just do IJK, but that's kind of painful. Let's do this one. So that's the B negative omega BA J. Negative cosine 20 times 15 omega BA. And then on this one, we get negative sine 20. 15 omega BA. What? That's just how it is, I guess. But I get different answers when I do these, is the issue. Like, on one of these we get cosine 30 over sine 20 times 0.15. And the other one, we get sine 30 over cosine 20, 0.15. Now, those are not the same thing. Unless they are, and I feel like I've done it multiple times, and I've lost my mind. $16.08 is the wrong one, and then there's a right one. So why? Why, though? Hmm. Hmm. Is there something about the way that I'm defining WBA, maybe? Nope. That shouldn't be an issue. I genuinely just don't see why that would be doing that. Well, we tried. Next problem. This is our omegas. Here's our alphas. That's all it got. That's all it got, chat. I don't know what to tell you. I don't know why it's doing that. It's kind of silly. Wait, I've only been streaming for half an hour? Oh my gosh. Me when I'm productive. Okay. I might have shot myself in the foot slightly trying to do this. But it's okay. VO equals, where's VO? Okay. We know what the angular acceleration, we know what this equals. This is alpha O cross with R. Well, yeah. Hello, how's it going? Let me lean over. Frigiolitor? We're just doing some intermediate dynamics. Well, I guess that means nothing. We're doing some regular dynamics. We got that there. So that's a known. Doing good, and you? I'm doing okay. Doing okay. Very busy, but it's always nice to come on stream and just be able to hang out and... Oh, we do know we know that angular. Oh, easy. Okay, it's rotating counterclockwise, and it's accelerating in the same direction. So we don't even need to... Also, that's not a V, that's an A. My bad, chat. Oh, it's because I didn't... Now, it's alpha R. Is this homework? Yeah, so I do lecture stuff, but in my lectures I don't do any problems at all. So I try to do streams of work, especially because I'm currently a student. So for other students, I think it's kind of nice to be able to see someone working through the mindset of it. Yeah, it's just a little chill, work with me, study with me type deal. 0, 0, clockwise. Angular acceleration should be coming out. So that would be 1, I guess, 1R. How large is R? 0.4. That does not look at times. It seems like pure gibberish to me. It's a little... It's kind of interesting. So I'm an engineer, and this is generally not how engineers write these things. I like to write it this way because I like math more, and I think that math is cool. So I write a lot of things in terms of column vectors, but these are all just vectors. So if you've seen vectors before that look like this is just that, but like I stood it on its end. And vectors are just arrows that point places. That's all we're specifying. We're just saying from the origin to some point. And all of our movement and all of our translation, rotation, all that stuff can be expressed in terms of vectors, and then you can say, oh, if I know we have a wheel and the wheel's rotating a certain way at a certain speed, and it's accelerating in that direction, then we can figure out like how fast this point is going. Or we can figure out, you know, those various things. And then for that, it's like if we connect it to something else, we can figure out how fast that other thing is going to turn, and we can control how fast those things are going to turn. So yeah. What am I looking for? I want the acceleration of point B, so AB. Did I use A? Oh, I did. Nice. unfortunately, this is going to be longer. It's the relative, so it'll be alpha O cross A B with respect to O, R B with respect to O, plus omega B with respect to O. Wait, I guess just omega O cross omega O cross R B with respect to O. I don't know if that's the same notation as I used up above. I should make sure it's standardized. I did, yeah. I tend to like to call with circles when we have a rotation. I just like to call, I don't like labeling it as a subscript. I like doing 1, and then I'll do 2 if it's a link. Alright, so we know AO. We're trying to find this one. We know this. We know this. We know this whole thing, and then we know this, so I guess we just gotta do it. Alright, AO, we got that up there, 0, 0, 0.4. Plus just a bunch of cross products now. And cross products are just ways that we multiply vectors, essentially, because multiplying regular numbers, we can say, like, 3 times 1 is 3. But when you have a vector and it's got a multiple elements in it, it's like, how do you multiply it? There are different ways you can multiply it. Wait, do I want alpha? That seems wrong, because that's not a vector. It'd be AO? Wait. Alpha O. Yeah, no, alpha O. Oh yeah, just as a vector. Drown him Friday? Oh my gosh, I can drown. I can drown him. I can hydrate. You scared me. I thought it was Friday for a second. I hope your little thing went well. I don't know what you're doing, but it's nice to have you back. We're just doing some acceleration stuff now. I still don't know why that other problem isn't working out. It's really weird. It's elusive. So in this one is just 1. Because that's what our angular acceleration is. And then B with respect to O, I think I defined it somewhere. Yeah, it's cos negative 0.4 cos 60. 0.4. Ooh. Switched layers, sorry. And then I really, one little tip, a trick, I will say, that I like about working with vectors is that we've already done this cross product. So we don't have to read. I like doing it as cross products because I find that I'm pretty fast with them. People are like, they're so slow. And I'm like, skill issue. I'm kidding. But like, we crossed these here. So this vector right here is that cross product. So I don't really have to do anything, you know? I just have to use that. And then it's just one cross product. And it's really not that hard. And, you know, if I want to put it into a calculator, it's pretty easy. If I want to do basically anything, it's great. Very easy to change into MATLAB stuff. So, okay, I've never done that before. I have to do that. Okay, so we've got everything negative. So we'll do negative 0.4 sine 60. And then that would be minus, but we're going to do another negative, so it's negative 0.4 cos 60. So we have, right, I minus j. And then we add that extra minus on there. And then for this one, pretty similar, but there's 4. It's 4 times 16. 16 is 64, 6.4. Is another negative, so we're gonna have positive 6.4 cos 60, and then that one becomes positive, but it goes negative, right? Is that right? Yeah. Yeah. There's a lot of negatives, a lot of positives. Right, now we just have to see if it's right, and if it's wrong, then we cry. And that's engineering for you. So negative 0.4 sine 60 plus 6.4 cos 60. It's a number. I don't think AO is supposed to be in the J direction. It's not. It's supposed to be in this direction. It's supposed to be here. What am I doing? What am I doing? I don't like that. I don't like that. That's not right. That's right. There we go. Because the alpha is in the K direction, right? Coming out at us, out of the plane, whatever. Or into the plane, and then when we cross it with the radius to get our acceleration, then it becomes in the real space. Well, not real space, it's all real space, but it's kind of rude to the space. Cosine 60 minus 6.4 sine 60. Maybe it's right, I don't know. 6.86, 2.85, and then minus. Okay. So first off, we got it in the right directions. At least we have it in the right axes, so that feels sort of right. Now, that would be going to the right and down. Does that make sense? Yeah, sort of. 2.45. We're off by a little bit. Which makes me think that maybe the 0.4... Oh, yep. Yep. It's not in the Y direction. It's in the X direction. I don't know why I keep doing that. I've done that twice now. Y is not X. X is X. Please, damie. Wait, it's supposed to be in the negative direction. Oh no, damie, please. Wait, it's rotating counterclockwise, yeah. Oh my god. Okay, let's try that now. Yep, because minus this minus 0.4 is 2.45. Okay, chat, we still got it. We can do the cross products. I just have to, like, get on top of my math. You know how it is. And this one is just, I'm gonna redo it. So negative cosine 60 minus 6.4 sine 60. Negative 5.74. Nice. We got it, chat. We still got it. Yeah, baby. Let's go. Okay. That always feels good. These aren't even hard dynamics problems, but I mean, it still feels good to get it right. Wait, why did I box in WAB? Oh, because that was one of the answers. Wait, why did I just stop? Oh, because I got it wrong. I forgot. Oh, this was the same problem I think I'm having with number 1. So I wonder if I can fix this problem. I can probably fix my issue with number 1. So let's see. We're doing VA first. So VO. Well, that's my issue. VO has a... what? Hello? Damie? I'm gonna make a new point called G that's at the... or I guess C that's at the ground. Because that's, I think, what I meant. And that's why I have a 2 in there. So that's that problem. Solved. Because this is 2. And this becomes 2. And then VB equals... wait, VA plus WAB Omega AB cross RBA. Why am I skipping stuff? What the fuck is this class chat? This is not Thermo. Oh, yeah. Yeah, this isn't Thermo because this is... My Thermo homework is this. What's the specific volume? What's the... Draw a PV diagram. I don't want to do that. This is lame. I should update my title. Bruh. This is so quick. This is so quick. I'm just gonna... it's so funny. But what's the class called? This other one? Oh, it's called Intermediate Dynamics. It's basically just dynamics, but in 3D. And we do more like linkages and stuff. Oh, hell no. No, it's easy, I swear. I swear. Look, watch this, watch this. Okay, I have all this stuff, right? Now let's like pretend it's in 3D. Literally nothing changes. Wait, so dynamics is taught in 2D first? Yeah, but because I don't like the way that it's taught, I just do everything in vectors, and then you can just do it in 3D and it doesn't even matter. But the thing that's different about it is, well, first off, like, we have a lab for it, which you actually do simulations, numerical simulations. So there's some like numerical solving of stuff, first off, and then the other thing that's different is that we do a different axis system, so you can have rotating axes, which I haven't done yet, but I know that we do it. We also do gyroscopes. So it's kind of just, and then mostly it's just dynamics in 3D. But the fact that it's dynamics in 3D is not just the fact that it's dynamics in 3D, because that's easy. It just is that the systems are harder, so it's not just like wheel rolling on hill. Like, these are easy systems right now, but this is like the review, so, you know. I'm mad that my thermo is so boring right now, though. Man, I should have taken a co-rec with fluids. Or not, it's not a co-rec, but I should have taken it at the same time as fluids. Then I wouldn't have had to have this guy. This guy's so bad. Fuck. It's okay. Let me see. So negative, this is a -2, and this will be negative, so it's positive. Okay, that's good. I don't really know what I'm doing here, so I'm gonna write it out instead. 2 omega OR. What are you doing in Thermo right now? I'm hoping Reynolds transport. I don't remember when your semester starts. It starts pretty far back, so probably Reynolds transport, maybe like maybe control volume. Maybe you're starting control volumes, but you also have a transport class, right? It's not necessarily just Thermo. I don't know. Maybe I'm lying. Wait, why did I... what? Oh, wait, VB is... I'm not defining it like that. I'm defining it with respect to C. Be first, I think. Yeah. VB with respect to C. And this is 0. So VB equals, well, I'll just write this out. So this is omega AC cross R, no, BC, sorry, B with respect to C. And that's what that other one was. Maybe that's why I was having issues. Do they give me a speed for that? Let's see. Nope. Fair. I don't really need a speed for it. Let's see, omega BC cross RBC. Man, I need more space. Get out of here. I might not be able to fit this all on one page, which is unfortunate. I don't like doing that. I don't like... But it's dynamics, so, you know. Maybe I'll just shrink it. So many of my professors this quarter are really... I don't know why they're doing what they're doing. Because, for example, I have to do like pre-lab memos for EE. I don't know if he just hasn't, like, looked at the pre-labs and seen that you have to, like, draw stuff for them, but he was like, no, just type everything up. Like, how am I supposed to type up, like, doing a circuit that's like this? I don't know what to tell you, like, that's all I got. I can't type it up, like. He was like, no hand annotations. Like, okay, cool. Like, also, do circuits. What? Please. Please, bro. 0, negative R0. Wait, maybe I just like did this in my head and I was really awesome about it. No, it's positive. I think I tried to do it by just skipping. Let's see, so that's negative, so this will be basically positive, so yeah. Maybe I just did a cross product instead? Like with my... Maybe I just did a cross product, he says, as he's doing the cross product. I mean, maybe I just did it in my head. Okay, WAV equals 0. Wait, what? CV times R. I like that. See, this is 2. Oh, no, wait, we're chilling. Because I'm trying to find WCB. Omega BC. Yeah, we're good. No, it's just not that. It's positive. Everything is fine. Everything's awesome. There we go. Yeah, I fixed my issue. My issue was that, there were a lot of issues. One of the issues was that I didn't have this 2 here. Which was bad. I was doing as if this point was fixed. Which would make it different, but this is translating at the same time, so it has a velocity. Which, you know, whatever. What are you gonna do about it? Sometimes things have velocities. You know what? Okay. So now we have to do the angular acceleration of link AB and BC. Which actually might not be too bad. Honestly, dynamics... My roommate's taking dynamics right now. So it's kind of nice that I'm taking the second one, so I can help him out with it. But really, relative motion is very simple. I think the things that start to get harder when you do the energy stuff, when you do the impulse stuff and all that, and you're trying to do all the moments and making sure all your moments are right, making sure everything is set up right is a little bit more finicky, I think. But really this stuff is just like, okay, if you can do relative velocities and you understand how to do those, then you're not going to have any issue with acceleration, because acceleration is just doing it again, truly. So let's see if I can consolidate anything. Nope. I can make the problem statement smaller. That might help. Yeah, that should be enough room. Okay, alphas. Put it here. There. So we'll start with V out. So AA. Wait a second. Okay, now we need to use O, because we know that the acceleration of O is going to be alpha R. So we're going to relate VA, AA, equals AO plus AO cross RA with respect to O plus omega O cross omega cross RA with respect to O. And now I guess the question is also, do we need this? Because we do. Because we're gonna do B with respect to A and B with respect to C. And then we're gonna be good. But B with respect to C is just rotating. So it just has... That's just alpha... Wait. I need alpha AB and alpha BC. We'll just do this for now. And we'll get there. I guess I don't really need AA, but maybe I do. So AO is gonna be that alpha. Alright, let's look at the wheel. It's going this way. I guess we don't know the... Wait, it's a constant angular velocity! Oh, it doesn't even have an angular acceleration. That means this is 0. This is 0, and this is 0. Oh. That's easy. Okay, it just has, I mean, it has some, because there's normal. Wait, that's so awesome. That never happens. Well, sometimes it happens, I guess it just happened now, but... Right, IJK. Then we need omega O. Where's our omega O? 0, 0, 0, omega O. Is that right? Is it going clockwise? Yeah. And then this cross this. I don't trust that. What do I need? I need omega O cross RAO. When did I do that? Did I ever do that? Chat, I might not have done that already. I might have to do that out. No, please don't make me do it out. Please, God. Oh no, fuck. Fuck, I didn't do that. Can I get away with not doing it? What if I just write VB instead? Let's just fucking people. I'm just gonna start writing it down here. AB equals AA. Uh-oh. Did I do AA? Not looking so good. Alpha AB. RB with respect to A. I mean, it's not the biggest deal in the world. It's really just a little bit extra work. One extra cross product. I'm a strong man, I can do it. My vector sizer. Getting a little silly with it. I think I might need to move this to another page. Fuck, that's annoying. I feel like I almost just used a 6-point pen on my fluids, not an 8. Maybe I did. Wasn't it? Oh. Alright, well, alpha AB we don't know. And then AC. Well, I guess AC equals 0, huh? Hello, you are suffering? A little bit, a little bit. Well, my pen just died, so, you know, that's extra suffering. I'm just suffering because my thermo is really boring and poorly taught. It's shifting my seating arrangement. There we go. Old man noises. Yeah, AC is 0, so I mean, I guess I could just say AB equals AC 0. Plus alpha. We do need alpha AC. Cross R. Omega is the angular momentum of something? Omega is the angular velocity of something. So it's just the regular velocity times the radius from a point. R, B with respect to C, plus omega AC crossed with... I don't like the... Wait, why am I writing A? BC, BC. Shit. Okay, yes, that's what I had in mind, but I was not sure of the translation. Okay, yes. Yeah. I'm trying to write the Morse Omegas. They kind of just look like W's. I need to move this to another page. Chat, we can't do this. I can't. It's too small. 4-1 or -2. Need to lock in. Accelerations. On next page. Right. Oh, look at all that beautiful real estate. Okay. What do we need? What do I need here? I think I do need alpha A, or need the acceleration at A, which is just unfortunate. Do I have math exercises? Well, okay. Yes and no. I do have differential equations stuff. That is in my intermediate dynamics activity, so that's the activity for this class. We do a lot of simulating in that. It hasn't really started yet because it's the first week. So next week I will probably be doing that at some point. And that's like, we're using MATLAB to do stuff. So there's some numerical solutions, but apparently there's a lot of derivation. So I'm looking forward to that. This one doesn't have as much differential equations. This is more, there's gonna be some probably later, but it's still kind of I mean, this is very basic. This is not like, you study Sobolev spaces to study them? Oh no, they just say, fuck it, we ball. That is the extent of our of our studying. They just teach us how to solve one specific equation usually in a certain way. So a lot of people say that the activity for this class, like it's like a lab. They say that it's like the hardest class that you take, kind of. Or one of the hardest classes you take. And it was so hard that people couldn't do any of it. So they had to start making it easier. So I'm excited for that. It should be fun. I'm gonna do this and then RAO. What's RAO? I already forgot. Oh, but it's nice because I can see it right here. From A to O. No. From O to A. Okay, sad. You do not know how to define differential when if a function is not differential. No, I don't know that. No. Feel free to help me out with that though. I'm not gonna lie, because any extra knowledge that I have of that is probably gonna help me out. It's a struggle bus. I am excited because finally I want something that's actually hard, because I haven't had anything that's really, really hard. The stuff, it's like, you know, sometimes I have things that are unclear. But maybe you know L to the P. Is that anything to do with Laplace, or is that completely different? I don't know what those numbers are, what those letters are when they're written like that. Storm realizes that when engineers solve problems, it's not really solving them. Negative, so that's positive, omega O, in the I direction. I wish I knew. God, it would make my life easier if they just actually taught us real stuff. You know, that would be great. This is J. Is that right? Let's see. K out towards me. Yeah, negative J. Huh? Wait. No. Yeah, K. Oh wait, no, it's up. It's positive J. Lol. Yeah, omega O squared. Wait, LP is all the function such that, wait a second, I think I might know that. Yeah, sort of. That kind of sounds like Laplace. Laplace is maybe similar. Like, we did that kind of stuff. I did solve, like, I did take a class on differential equations. We did Laplace, we did Fourier series. But things like, we don't even take a class on partial differential equations. So we're really kind of uber fucked, if you think about it like that. So, you know, really flying by the seat of my pants. LP is a vector space, and maybe you know that we can define integrals of functions which are not differentiable and even not continuous. Integrals of functions which are not differentiable. I mean, we never explicitly did that. So maybe not, but I mean, if I came across it, maybe? I don't know. We never really explicitly did that. Theta is negative 2r. I plus O. So there's another cross product here. But she's gonna look at this, she's gonna be like, don't do all those cross products. And be like, but they're right, so please. Was that BC? Or is that's AB cross BA? Let's see, do I have that anywhere? Wait, yeah, it's right there. Oh, it's here. 2R, 0, 2R. Oops. Wait. For example, the integral of a stair. F of x equals 0 when x is not in 0, 1. Oh, like piecewise? Yes. I mean, yeah. We did that with turning it into a Laplace, I think. And then integrating. Well, no. Integrating a Laplace? No, we wouldn't do that. I know how to write that function as like a continuous like thing. Not a continuous thing. A repeated thing. What is omega BC? Did I find that? Where is omega BC? What direction is omega BC in? Hello? Hello? Oh, I guess it's... Yeah, I guess that would just be in the K direction. Oh, because it's an omega. So what was it? 2 omega. Ah! Yes, that's an example, but in reality, more generally, we can integrate some functions which are not even continuous piecewise. I think maybe we did that. But like, it kind of depends on the situation, I think. Because in reality, a lot of engineering functions are not that weird, I guess, or if they are weird, you don't solve them by trying to find the actual solution. Like the intermediate dynamics activity, we do a lot of numerical solving. So it's like you're taking a differential equation and then turning it into an algebraic system and then numerically solving that. Yeah, I would love to see an example. That'd be great, actually. And then, sorry, I'm still just trying to... I need this vector here. Oh, you can't see that. I need this vector here. And that one would be... This is like a tangent. This is like its own thing. And then we come back to that equation. And this one is here, which is 0 to r, WAB. I think. Oh, the transport equations. Yes, we did do those. Oops. My best friend, Mr. Reynolds. JK 00. AC. You know, it's honestly very relaxing to do these. I think. Get to this snack. I should probably eat lunch before I go. Yeah. My 3 to 6, and then my 6 to 8. It's probably not gonna be 3 to 6 to 8. Maybe it is. I looked at, oh my god, I looked at my lab professor's PDF. And it was a picture. It wasn't even scanned. It was hand-drawn notes, and he just took a picture of it in yellow light. I was like, dude, I'm living in an engineering sitcom. There's no explanation. This equation explains how your function will move. Sure, yeah. It like keeps track of, you know, different things. I guess at its core it is just about the movement of the function though. We take a stair signal, which represents an electrical signal. Signal's not differentiable. You can't put it in the equation. Ah, yes, okay. Yeah, makes sense. Here, this one. WBCR. At the top. But we're pretty sure that the signal will move in the same way as if it was continuous. Okay, I see that. So it's sort of like you're, you know, like when you're in a limit and you're saying, oh, if it was going to this place, then it would be like doing this stuff, but we have like a hole. So maybe it's not exactly doing that stuff, but -2R. I don't know why I wrote that. Okay, we're not out of the water yet. That's negative. Doesn't really matter, because that's that. I don't really see where we get a 5. And to prove the pretty sure, we need Sobolev spaces. Okay. So what is a Sobolev space? Am I saying it right also? Probably am not saying it right. That sounds cool. So it's like weak differentiation. Oh, that sounds really cool. Weak differentiation. I love that. It's like, nah, bro. We don't need that full thing. That's kind of dope. I'm trying to find. Oh, the 2 alpha ACs, I guess. The 2 alphas. So low key, I'm not getting the 5 halves thing going on here. BC is supposed to be equal 0. The other one's supposed to be 5 halves. Wait, why do I not have a BC? Where'd my BC go? Wait, what? Huh? Wait. Alpha AC, damie. AC does not exist. That is supposed to be BC here. Me writing all that stuff. Alpha BC here. Alpha BC. So AB, was AB 0? Oh, okay, so it is 0. She doesn't get mad about that. I do like to write sometimes flipping it backwards. Let's see, it's a space of function which can be weak differentiated, in which are L2 and verify some conditions, but I'm not sure to remember the condition because I don't use these spaces all. That's so real, honestly. That's I was okay, you know what was actually so funny? My thermo professor, he worked in like aerospace. Not aerospace. Aeronautical, I guess? Whatever it's called. He designed missiles though. He was like, okay, what do you need to assume? He's like, for example, he was talking about systems. He was like, for example, for Bernoulli's equation, you need to assume that the thing is incompressible. And I was like, that's not all you need to assume. Like, that's definitely not all you need to assume. Like, you can't just use Bernoulli's because it's incompressible. I was like, no, he said like, okay, if you assume that air is incompressible, like, what does it mean? He's like, it means you can use Bernoulli's. And I'm like, what? No, you have to assume inviscid. That's so different. That's so different than assuming incompressible. Because I thought it was going to be like, he was like, oh, you can assume like, okay, air is incompressible. And I was like, oh, I'll just say like, okay, constant density, right? So it's like, then you can, you know, get like cancel out density in your equations or something like that. But he was like, no, you can use Bernoulli's. And I was like, dude, what? What are you talking about? Just in terms of the assumptions. But like, I didn't remember enough. I was like, I'm pretty sure there are more. But I was like, I can't remember exactly which ones. And then I couldn't remember which ones that you need for the Euler, which is slightly less strict than Bernoulli's. Euler, you just assume inviscid. Bernoulli's, you have to assume steady, incompressible, inviscid along a streamline, which is like, that's a lot of stuff to assume. I mean, it's over a streamline though, so it's like, not as bad, but still. Anyway, that's my yapping. Done. Equals... Oh wait, maybe it's because omega b squared r... Oh shoot, uh-oh. This needs an r, I think. Where is that? What the, what? Oh, not 1. There we go. That's funny. I just thought it was 1. Okay, so no r is necessary. So that's over there, and then we have the minus WO squared over -2. And if we do that, then WBC is 2, right? Yeah, so it's 4 omega O squared minus. Wait, it's 3. Oh fuck! I'm messing a sign thing. And now how to define a weak differentiation. Oh whoa, my tracking. A function f is a weak differentiable if there exists a function v such that for all c infinite functions which are bounded, we have an integral f d... what is that? F d... oh, dt u? What? ddt of u is integral of uv? My condition on u is a bit too much. You can just take u, which is differentiable. Is this a function v such that all u belongs to, I guess, like the, what is that? Complex? Or is that like a polynomial space? Been a while, man. I don't know what's going on. But the bounded is important. So essentially you're saying like... is this function v? Is it that it's made up of functions, or is it that we have a function that we're using that's similar to the other one. I'm so close to this. There's one negative I'm missing. It's in this one. This one should be negative somewhere. Let's see, R is negative. That means that's positive. This is positive. That should be negative. Fuck. See, infinite. Oh, differentiable infinitely many times. Okay, but like how, like what does that like mean? There exists a function, like, I mean, I get it, but it's like, are we saying that, so we basically can't differentiate a function, but we know that it's close to a differentiable function. So how, like, how do you get there? Okay, I see. We have f at the beginning, we must have a v which works for all the u. So it's like if we're saying, okay, if we, basically, we have a function, it sucks. But if we have another function that works for everything, for all the u, and does the same thing, but is like continuous or differentiable or whatever, then it's good. I don't know if that's like, it's very simplified, but I don't know if that's kind of how you do it. I'm mad that this, because this is that, there we go. It's like a puzzle. It's like I'm missing a piece and it's like I need to flip the piece over, you know? There we go, negative. Wait, no. Yes, positive there, it becomes negative 5 halves. WI squared. Wait, she says she didn't like that. I'm actually gonna move these down. That's, like, it's like that's getting to the point where there's a lot of equations on them now. Yay! Yippee! Okay, these are done. I think that's right. Let me just double check. Wait, it's supposed to be positive. Fuck, why is it positive? God damn it! No way. Let me see, okay. Well, here's what the idea. We have a function which cannot be differentiable, but the integral is well defined, so we look at the integral instead of the differential. And we just want that function to have a property similar to integration by parts. Oh, that makes sense. I kind of get it. I mean, I don't, but like, I feel like I kind of get the vibe, do you know what I mean? That's interesting. Maybe I'm messing up. Why is this negative? Is it supposed to be negative? So why is there an R there? There should be an R here, not an R here. And do I define it as negative? I do, okay. That's positive, and so this... Wait, why is this? This shouldn't be negative. Frack. It's not done yet. The sign flip. It's really not that big of a deal. I don't know why though. It's there. Oh, this one's done. Wait, this one is done. And this one is also done. Wait, we're kind of chilling, chat. I basically just have to figure out the sign issue on this one, and I have to figure out why this one is not working. This one is, I don't know what the fuck is up with this one. I say we don't worry about it right now. When you have this and you want to prove that your function is a solution of a partial differential equation, we integrate the equation. At the end, we find some idea to erase the integral. So in general, when you solve partial differential equations, you will have a solution which works almost every way. Say it another way, your solution will not just work on a space which has a measure equal to 0. Okay, most of that went over my head, but I think I kind of get it. Is it that our solution doesn't, when you say almost everywhere, it's like it just doesn't work on in certain places, but it'll work for most of them? Or because I don't know if you're talking about like different spaces or not, you know? I'm gonna do a little bit of EE. What is the one that's easy? This one might be easy. No, that one's the hard one. Sorry. Wait, where did my... Oh no, did I goof it up? I might have goofed it up, guys. I might have goofed it. I might have goofed it. Oh, I did. Damn it. I'm gonna have to pull this up real quick. We're just doing like everything today. I did not mean to do that, but I guess we're doing that. I'm gonna have to change this title as a first stream for what's it called? For upload. Was on for it's in my library. There we go. And then principles and applications of engineering, electrical engineering. It's so funny. The professor was like, "Yeah, so this textbook is really not very good, but we don't have any better ones." And I was like, "Oh my god." Can you at least pretend that it's good? Can you at least please pretend that you guys are on top of something? That's all I care about. Just like make it seem like you're doing the right thing. Okay. Let me see what the actual problems are for this. Homework 2 diode. I think that's what it's called. Alright, to say almost everywhere, the space where it is not, where it doesn't work is have a measure equal to 0. At the end, you will never know where it works and where not. You just know that it works at almost everywhere. Okay, that's kind of funny. Yeah, so the only partial that I've solved is basically just the heat and wave equation. And we just kind of did those, and they're just, like, separable. So it's not really hard, I guess. But if you have some condition on your function, you can turn your almost everywhere into everywhere. Oh, I see. Let me see. This is 9. I'm looking for problem 9. That's 8. What the? What? Wait. Oh, wait. It's chapter 8, problem 9. Oh my god, I'm losing it, chat. Oh, we're chilling. Okay, I actually think I can do this one. So we're doing... I have an electrical engineering class, which, you know, is never really fun. I'm kidding. E's not bad. E's not bad. It's just, like... It can be complicated. Ooh, okay, VA equals 12 volts. So this is the positive, negative. I'm just gonna do that first. So in my mind, this is 12 volts. I guess I should choose a ground. Oh, this is the ground. It's at 12 volts. Oh god, okay. Yeah, okay, it's coming to me. The little brain is starting up. Okay, 10 volts. It's not too bad, it's not too bad. So... all we need to figure out is... this is 0 volts. We just gotta figure out the... I said viscosities, the voltages on either side of the diode, and then we gotta see if it goes the right way. And if it goes the right way, then it's on, and if it goes the wrong way, then it's not on. Which I like. That's pretty easy. So we just gotta figure out the fastest way to do that, and it's been a while since I've done that. So let's see. We know that I literally just reviewed this, so We know that right here is 12 volts. And we know that right here is 0 volts. But I need to get the voltages over these resistors. Do I have to do node voltage analysis? Oh no. I think I have to do. Why do you not write your resistance with a rectangle? It makes me remember some memories when I met you. I studied this type of thing in math. Oh, that's dope. It sounds cool. I honestly want to look into it a little later. Why do we not write them with rectangles? That's a good question. The convention is just to write them like this. So that's a resistor, this is an inductor, this is a capacitor, this thing is a battery, but also a battery could be other stuff, but batteries could also be like, I don't know, like this. Yeah, I don't know. It's just a way that people ended up doing it, I think. The invention I studied with a rectangle. Oh, interesting. I wonder, let's see. Rectangle in EE circuit. A relay. So, one with a cross through it is a fuse. This is a resistor too. Apparently it's also a resistor. Maybe it's because it kind of looks like it could accidentally be a loop. So how you write a variable resistance? Let's see. I would assume it just is some like little thing here. Wait, variable resistor. I guess you just kind of label them. Oh, I think you maybe do... It's either you label them or you do something like this. You draw like an arrow through it, I think. Maybe. Something like that. It's a rectangle with an arrow. Yeah, I think we have just like... Yeah. I think it's this. It's like a resistor with an arrow. I don't know, we don't have to do that, so... Oh, look, here's one. That's what it is. Fixed value, rheostat. Oh, so yeah, it's just basically just do you change it into a rectangle or not. That's funny. Okay, so I guess I have to do node voltage analysis. This is gonna be a gauntlet. Well, I know this is 12. I don't know what this is. This is VA. Sure, that should be fine. Well, I don't know the voltage. Wait, I do know I don't know the voltage of basically here. I don't know how much that drops it. So I guess I just pick a loop. Fuck, it's been a long time since I did this. But then you have to like do the currents for node voltage. You use the currents even though it's node voltage. But you say like, so we say like 0. If we start here, then plus 12 volts. I forgot a lot of electronics, but I remember that it was entertaining. Yeah, it's fun. I just have to get back. I really didn't have a very good professor for my first class, and it was like, here, look, this was my review. I watched my old VOD. I remember, what is that? Lloyd and nodes and Lloyd and Wise, but I don't know how to say it in English. It's been a long time since I took French. That's not how you pronounce it, I'm sure. Use I equals V over R to make a system. Bro, damie, I wrote that. I can't use this. It's like I1. Oh, it's like where it splits, right? It's like we're gonna say like, I don't know, it's like splits here or something. Like we have to say like, okay, I think that it's gonna go in here, And it's gonna go out this. Yeah, I vaguely remember this. Vaguely. Law of knots? Oh, well, I mean, there's like the Kirchhoff's voltage and current laws, which are kind of what like these are based off of. Man, I don't know, this is gonna be rough. This is gonna be rough, Jack, but that's why I'm here. I'm here to be that guy who's like, it's rough. So, for this one, it's like VA minus 12 volts over 5 ohms is this current going in here. And then that equals 10 volts minus VA over 10 ohms plus there's no resistor there though, which is hard. Well, there is a resistor, but it's not like right there. What happens if you have a current source there, or voltage source there? I don't know. Oh, shit. Fuck. Shit. I mean, I guess I could just say VA. Sure. VA. Let's do this. 0 volts minus VA over 5 ohms. We're gonna try that. There's also a big formula to compute equivalent resistors. Chicken on screen, yippee! I feel like I don't have enough nodes. I have 1 node. This is like not right. Also, I didn't multiply this by 2. Fuck. Oh, chat, we're cooked. Oh god. Okay, 0 volts is nothing, so it's just minus VA. Minus 2 VA? 5 VA equals 34 volts. VA equals 34 volts over 5? I don't know. What is this? Oh, it's Big Bird. It's chickens. It's just chickens on screen. My little guys. I thought you were like asking what the circuits were. I was like, I don't know, it's a circuit. You know, I know just as much as you do. Well, I don't know how to get the... Wait. This is 10 over here. But I need to know what the one here is, don't I? Yeah, I need a VB here. I think this can be not VB. I think that doesn't need to exist, but I think that needs to exist. So instead of 10, this is VB. And then that one's fine, maybe. And then VB. I don't know. A black chicken? Chickens are orange? I think they're black chickens. Chickens are orange. I've never seen an orange chicken. Let's see, 10 volts minus VB over, but this is like the same current. Like, what am I equating this to? My teacher would be angry if he saw you like write your letters and numbers together in your formulas. Well, okay, fair. That actually is fair, because I was supposed to say, but then I have to name them something else. I can't name them V. I feel like the more annoying thing is that I'm naming VA something different than VA. I have 2 VAs right now. Oh, this is so bad. This is so bad. Let me. You know what? We need to delete. We need to absolutely decimate this and just redo it because it's that bad. Sometimes just wiping everything is the only way. And you know what? I think that's beautiful. Okay. I keep turning on the ruler. What if I made it really big so I can actually write on it? That would be nice. Okay, literally all I need, just conceptually, is the voltage here. I'm gonna call this V... We'll call it V in and V out. That seems like pretty good, right? I guess I could do superposition. That could be a way I could do it. So this is 0 volts. And then we know that here, this is 12 volts. Then we have a resistor. Maybe superposition would be the easiest way to do this? Because I mean, it's really not that hard of a circuit if you don't have 3 things in it. Wait, maybe we're crooked. This is 5 volts. And this one is 10 volts. So this over here is 10 volts. Okay, let's just try superposition. I don't know, I don't have anything else to do. I can't do anything else. If we have VA, and then we have, for voltage sources, we have to short them. And then the diode, you know, whatever. Okay, so this is our circuit right now. Well, it's not connected to anything. Shit, we can't do superposition. There's no circuit happening. We just cut everything up and there's no circuit, right? Fuck. We offered a tampon to our teacher to not write letters and numbers together because we wrote that every time when he corrected our exams. I guess if I remove C, I can do superposition. But if I remove VB and VC, then I'm fucked. I can't do that. God damn it, chat. My electrical engineering did not prepare me for this. Maybe there's some answer in the book. Maybe I can mooch off of them. Large signal models, PN junction, and do they have any, like, examples, maybe, of, like, nope? Wait, example. Okay, determining the conduction state of an ideal diode. Wait a second. Yeah, the chickens go away. I mean, I can bring them back if you want. There they are. Wait, okay, wait. Chat, we're cooking. Wait a second. Let me come over here. That's a deal. It was 3 years before I can explain, but I forgot all of it. That's real. Okay. Assume that the ideal diode does not conduct and replace it with an open circuit. Oh, it does not conduct, so we say that it's off, I guess. Yeah. The voltage across R2 can then be computed by using a voltage divider rule. So across R2... Where are we? Where's R2? What the what? Oh, this one. Here. By using a voltage divider rule? V1 equals R2 over... I guess... Wait, V... Oh, because this one is not... adding anything? See, that's not the hard part I didn't really get about EE from my class. I just do fundamental maths, so if you want to do maths, I can explain. Yeah, for sure. Don't worry. I'm definitely gonna ask for your guidance. You might not be able to answer it, because it might just be really specific, but when I start to do those numerical things... So yeah, VB I think just doesn't really exist because it's not connected to anything. That's the hard part. That's what I like don't understand. I feel like electrical engineers just sometimes like are like, yeah, this thing like doesn't do anything. I'm like, why? What? You can just say it doesn't do anything? How do you know that? Please. You want to see a beautiful theorem? Look up von Compen theorem. I love that you use those emojis. It's funny. Let's look it up. Why not? I don't. This is going poorly. Whoa. What the heck is this? I can't read this. There's like some... Dude, math is actually wizardry to me. What the heck? There, make it a little better. Look at this thing. That's awesome. I don't really know what it is, but what is this? A connected union of two non-connected spaces with a set of base points? What? Two sphere? Okay. Oh my god, this is so... I don't even know math, bro. I don't even know what this stuff is. That's what I study currently. It's a theorem to compute the fundamental group of a space. Oh, that's dope. That's really cool. I really wish I could take a proper math course. Man, that would just be so cool. Okay, I'm gonna redraw this without the diode. Like they did. I think once I get into it, it won't be too bad, but right now it's gonna be really painful, is what I'm feeling. But like, it's okay. We're gonna get it. Alright, so because of that means this one is like not on. So these two are on. Here. And here's the ground. That's not what that is. 0 volts here, 12 volts here. But now what do I want to get? So if I apply KVL to the right hand side mesh in which the current is 0 to obtain V1 and V2. Oh, okay, I see what they're doing. So let's call it V1 and V2. So I guess I can just like do... Does it matter if, like, what order they're in? I don't think it should matter, right? Or does it? Maybe it does? The fundamental group is the group of all the loops you can draw on your space. But if two loops can be deformed one into another, you take one of them. So for example, the fundamental group of the sphere is just a loop where you don't move your point because every loop could be deformed into just not moving. I have no clue what any of that means. The fundamental group is the group of all the loops you can draw in your space. Okay, okay, got it. So it's kind of like you only want the... What are they called? The unique loops. I get that part. For example, the fundamental group of spheres is a loop where you... Oh, okay. So you just have one loop because they're all kind of the same loop for a sphere. Wait, wouldn't V2... If we have V2 here... Well, so this is 12 volts and this is 5 volts, so we're gonna assume that the current goes this way, I guess, first off. You go here, you drop, then you add 5 volts. Isn't this just 0 though? Isn't this 0 volts? Because this wire is 0 volts? Yeah. So this has to be larger. This has to be like, I mean, like, I don't know what it is, but it has to be like something. It probably wants me to say what it is. Yeah, a space where every loop can be deformed into a loop that doesn't move. We say the space is contractible. Ooh. Cool word for it. I like that word. I'm struggling, man. This is unfortunate. Can I just do... Okay, what if I just very basically do this? I say 12V plus VR1 plus 5V plus... I guess minus, sorry. VR2 equals 0. We know that's true. But we need another equation. Which would be what? I don't know. What would it be? I mean, I could start making stuff up about the current, but that seems... The way that they did KVL was... V1 equal... Yeah, but that's so easy. V1 equals VD plus VB My chickens can save me. It's like, it's very similar to the problem that they're giving, but it's slightly different because they have another battery. Oh, there's another one. Let's try, let's see. Maybe this will be helpful. That's the wrong one. Wait, over here. There we go. Assume initially that the ideal diode does not conduct and replace it with an open circuit. Okay, we did that. The current through the resulting series loop is, so if we do that, wait, but that's just one loop. Man, what the fuck? God damn it. They keep giving themselves the easy ones and then they do the hard ones here. Your chickens know the answer, but it lets you think before helping you. Oh, that's a very sweet thing. Okay, maybe it's a current. Maybe I do current. I think it makes more sense to do current because there's like a current thing here. So let's see, that'd be 12 volts minus plus 5 volts over what were the two? 5 ohms plus 5 ohms equals 17 over 10, 1.7 amps. Okay, so we have the current. Now we can say... Okay, yeah, now we can say what the voltage is. Holy shit. Oh my god. Okay, so V1 equals I1 times R1. 1.7 times 5 is what? 8.5. 8.5 amps, and then if we say that... Yeah, because the current is the same throughout all that. Okay, cool. Oh, I didn't flip back over. No, volts. So that's how much it drops. That's not V1. That's VR1. So V1 equals 12 volts minus 8.5 volts, which is 3.5 volts. And that would be 0. So 3.5 volts And if we do this, then yeah, it's just 0 because this wire is 0. So if we just check that, so 3.5 volts, 8.5 volts, and then the other one is also 8.5. Cool, good, yes. So it's on. 3.5 volts to 0 volts. Wait. Is that right? No. That goes this way, doesn't it? Which way does the current flow, if you have that? It flows from... If you have like 15 volts to 5 volts. Did I write that down? Let's just check. Positive negative sign conventions are making me lose my mind a little bit. That's like one of the worst parts of EE. This is fine. See. Yeah, it does flow that way. Okay. So that means it's good. It means it's on. I mean, if we want it to be on, it's good. Otherwise, it's bad. But I think we probably want it to be on. My chickens did help. They gave me a little hint. They said, pss, 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 pss. I should probably do another one of these. I'll have to rewrite it nicer, but yeah, okay. So it's on. Wow. Alright, I think that is a good place to end for today, because I gotta go get some lunch before I have to walk. And I gotta walk at like 2:20. Oh. So that was everything. Literally just everything. I don't know. I didn't expect to be doing everything, but I also didn't think my thermo would take me. I don't like doing problems that are really nothing burger on stream, if I can help it, so I don't wanna... Some of it I can do, but some of it... Yeah, the other thermo we'll do on the Tuesday, and then... Yeah, I'll try to plan it out a little bit better, because I have a lot of weird deadlines. So, like, we might be doing Strength and Stiff Tuesdays, and Thermo and Strength and Stiff Tuesdays, and Intermediate Dynamics, and then... Oh, that's neat. Formula, send it in Discord. Can you rate it? For sure. Let's see. It's gonna be... Oh my goodness gracious. Sigma to the pi? Is it a matrix space thing? I don't even know what that little half pi guy is actually called. Infinity. This thing equals sigma minus... Is it recursive? Let's see, pi. That thing. Sub. What are the subs? What does that notation mean? And then we got double that thing. Integral. I would rate this. This is like a very regal formula, I think. It seems a little like not CEO, but like CTO. You know? Not that that's really regal. I would rate it out of 10? I think it should be above and below for subs and supers. Oh. Oh, just a rendering error. Okay. Yeah, the notation I feel like is very confusing. I'm not really sure. Oh, those are limits. Oh, the bounds of the integrals. And is that pi, or is it something else? Is that just like a number that you would put in? I would rate this 7 out of 10. 7.5 out of 10. It's just x to the y, e to the y, ln x. Oh, okay. Yeah, 7.5 out of 10, I'd say. That's what it is. I like it. It's cool. It's fancy. It's a great closer for the stream, because I gotta go. I gotta go walk, but instead of using letters or numbers. I used Greek letters. Well, you also expanded some stuff, to be fair. There's a sigma in there. That's a series of some kind, right? You're representing it as that. Have a nice evening. It's afternoon, but you have a nice evening, and I hope you have a great day. I'll be back Sunday doing, I don't know. I don't actually know what I'll be doing Sunday. It could be anything. Hopefully it's intermediate dynamics. They probably won't give me an activity that early. Maybe it'll strength and stiff. Alright, I'll see you guys later. Bye.